All right, let's work this problem out. I've got two charges, Q1 and Q2. Q1 is 2 microcoulombs, and then the Q2 is 3 microcoulombs. And there's a force, a repulsive force, of course, between them, which is given to be 0.5 newtons, and we want to know how far apart are they, which we're going to use the letter R to represent how far apart they are. And then we're going to draw the electric field. So let's get started on part A. So we know that the force between two charges is given by Coulomb's law, which is the electric constant times Q1 times Q2 over R squared in the R hat direction. So the force is given to be 0.5. Well, so let's go ahead and say that, okay, this is equal to 0.500 newtons in the R hat direction. We can just cancel out that R hat. And we're going to solve for R squared. Solve for R. So R is going to be equal to, well, I'm just going to multiply both sides by R squared, divide both sides by 0.5. And so we get K Q1 Q2 over 0.500 newtons. And we have to take the square root, right, because it's R squared. So I did all that algebra one step. You follow that? Okay, just solve for R. Now I'm going to plug in values. This is 8.99 times 10 to the 9. And this is something you should write down on your equation list. So, you know, it's easy to memorize, and it's Newton meters squared per Coulomb squared. And Q1 is 2 microcoulombs, and Q2 is 3 microcoulombs. And I'm going to write the micro in there. Just remember when you type it in your calculator that the micro means 10 to the negative 6. And then I'm going to divide that by the force. Now let's check the units. Newtons cancels newtons. I got a coulomb and a coulomb. That cancels with the Coulomb squared. I'm left with meters squared, and I'm taking the square root of meters squared. So I'm left with meters. That's good. The units work out. That means I'm doing things the right way. So let's get the calculator out. And so it's going to be 8.99 times 10 to the 9 times 2 to the negative 6 times 3 times 10 to the negative 6 divided by 0.5, and that's equal to 0.1. And now I have to take the square root of that. I have to remember to take the square root. So I'll just raise it to the power of 0.5, and you get 0.328 meters, or 33 centimeters. So about that far. Okay. Now, any questions on that? Okay. Did any of you get that far that quickly? I didn't give you much time. Okay, did your answer match mine? Okay, good. All right, so here's part B. Now, this one's going to be kind of interesting because I'm going to draw the charges. Here's positive 2, so and then here's this one, and let's see, what did I do? I should have 1, 2, 3, 4, 5, 6, 7, 8. So this one I should have 12, right? 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. It doesn't really matter how many pluses you draw.
Oh,
yeah. But now the field lines are going to come. Well, first of all, if I'm a little positive test charge, I'm going to get pushed away from this one, but this one's got more charge, so it's going to push me away. And this one, on this side, it's going to kind of get a little bit further before it gets pushed away. So it's going to be unbalanced. And I think what I'll do is I'll draw, maybe I'll draw 4 field lines for this one, but I have to draw 1.5 times. This has, you see that this has 1.5 times more charge? So I have to draw 1.5 times more field lines. So what's 1.5 times 4? It would be 6. So 1, 2, 3, 4. And then this, I'm going to draw more field lines. Okay, and there we go. And let's see. Let's see if this follows the rules. It starts at positive charge and ends at negative charge. Well, these have no end because there's no negative charge drawn here. But remember, the universe is electrically neutral, so these negative charges are way out there in the universe somewhere, and they just terminate at infinity. I've kind of shown the space around it. I've got arrows. I didn't cross any field lines. But most important, the number of field lines I drew is proportional to the amount of charge. So I just said, well, now I arbitrarily chose 4. So look, 4 field lines. Well, there's 2. So that means if I draw 4 field lines to represent 2 microcoulombs, I have to draw 6 field lines to represent 6 microcoulombs. Yes?
Would it be incorrect to do 2 and 3?
Would it be incorrect to do 2 field lines here and 3? I'd probably ding you a point, just because how do you represent the space with only 2 field lines? You want to kind of show what's going on around it. So if I give you something like 2, just double it or triple it, or just come up with some easy to do fraction or multiple of how much charge it. But I mean, sometimes, like, what if I had given you like 20 microcoulombs here, or 30? Would you have to double it? No, you could still draw it with 4 lines and 4 lines here. They just have to represent the space, enough to represent the space and stay proportional to the amount of charge. Okay. And where I place these field, I mean, obviously I could put a field line here, but if I put a field line here, I would have to put 1.5 here. So I'd have to put, if I wanted to put more field lines on here, I just have to put 1.5 times more on this side. Okay, and there's our problem. Any questions? Okay. That is all.